Hello everyone, and welcome to another Mathematics and GIS Statistics tutorial video. And in this video, I want to talk about something called hypothesis testing. And sort of as an offshoot of that, the p-value. And the reason that I'm putting this in this particular spot is because basically from here on out, a lot of what we're going to be doing in the inferential statistics is going to be in some way, shape, or form a version of a hypothesis test. And when you have hypothesis testing, at least in many cases, your decision, whether it's a good idea or not, is going to be largely driven by this thing called the p-value. So understanding what hypothesis testing means and what a p-value means is extremely important. So let's go ahead and start with what a hypothesis test is. Right, what is a hypothesis test? Right, and if you're familiar with the scientific method, right, you've heard the term hypothesis. Right, and a hypothesis is basically just a fancy word for a question that you think you know the answer to. Right, so in statistics, right, So hypothesis is just a fancy word for a question that you think you have an answer to, and you're testing whether or not that answer is correct, right? And so some examples of some hypothesis tests that you're going to run across in statistics are things like, do these two samples come from the same population? Right, this is a question that you'll see a lot with something like the t-test, or you might say something like, is this data normally distributed? Or something like, are these two variables related? So these are some examples of things that you might consider a hypothesis, right? So do these two samples come from the same population? Right, and you may say, well, I hypothesize that they are, and then you would do a statistical test, and then you would calculate a p-value, and the p-value would sort of indicate whether or not you are confident in your answer. So these are some examples of some hypothesis tests. And so for each hypothesis test, right, we have two things. We have what's called a null hypothesis, which you will often see designated as an H naught. Right, and then we have the alternative hypothesis. Right. And it's very important here to know these terms, the null hypothesis and the alternative hypothesis. So basically what we've done with these hypothesis tests and hypothesis testing, right, is we've set up these questions in such a way that there's only two possible choices, right? Do these samples come from the same population? Yes or no. And then we're going to set up some sort of statistic that we will run, and then we will calculate a p-value, and that p-value will be related to the null hypothesis or the alternative hypothesis. And so what's extremely important, and I'm going to repeat this, what is extremely important when it comes to hypothesis testing is on a test-by-test basis, you need to know what the null hypothesis is and what the alternative hypothesis is. Right? So for example, do these two samples come from the same population? Right? If your null hypothesis is that they do, right, then you're going to want the null hypothesis to be correct if your goal is to prove that they're from the same population. But if you're asking the question, do these samples come from the same population, and you are hoping that they're not, right? You're hoping that these are two different populations, right? Then you're going to want to make sure that you're able to prove that the alternative, that you can reject the null hypothesis, right? So it's really important on a test-by-test basis to know what the null hypothesis is and to know what the alternative hypothesis is, so that when you're interpreting the results, you know what you're actually saying, right? Do these, again, is this data normally distributed, right? If the null hypothesis is yes, they are, and your p-value indicates that you do not reject the null hypothesis, then that would indicate that they are normally distributed. And if that's what you want, you need to know that, right? If you use a different test, right, the null hypothesis may be that they're not. And so you would interpret that differently. So to repeat that again, right, for every test you run, you need to make sure that you know what the null hypothesis is and what the alternative hypothesis is, so that when you run your test and you run your p-value, you know what you're getting. So hypothesis testing, you have a null hypothesis, and then you have an alternative hypothesis. And then for every test, right, there is some statistical equation. Right, so you have a null hypothesis and you have an alternative hypothesis. Right. And then you also, right, for every, in statistics anyway, for every hypothesis, right, you have a statistic equation, and that statistical equation produces a test statistic. Right. And this test statistic, this is really where your p-value is going to come from. So knowing what test you're using, knowing what the test statistic is, getting a feel for what the test statistic is supposed to look like is extremely important. So not only for each test do you need to know what the null hypothesis is, what the alternative hypothesis is, you also need to know what the test statistic actually is. And then finally, and we're going to talk about this in the next video, you need to understand what the p-value means, right? Or how to interpret the p-value. So you need to know what the null hypothesis is, what the alternative hypothesis is, know what the test statistic you're actually calculating is and what it means. And then finally, you have to wrap your head around what the p-value is. And we're going to talk about p-values in the next video. I know I went through this kind of quickly. I was hoping this would be a review for most of you. If you have any questions, please reach out. Thank you.